Hello everyone and welcome. This is the CyberSecStudy CISSP video bootcamp series. You're watching the free version of this domain. For access to the full version, go to the website at www.cybersecstudy.com. So hello everyone again, my name is Donald Parker. The reason you're watching this video is because you're interested in obtaining the CISSP certification, and in some cases you need it, right, for your job. The reason I'm here is because I developed a training program that can help you get past this doggone exam. So the program consists of a book of the course material, audio recordings of all of that content in the book. We have the video recordings now of all of the content of all 8 domains. I developed a Jeopardy style game that has questions that are based from the course material, and then a Kahoot competition style game where folks can compete and test their knowledge of the information in the course material. So this is a copy of the book. It's a little thicker than I really wanted it to be. But this is a hard copy version of the course material. If you purchase the audio or the video, then I'll also give you a soft copy of this course material. So for the book, it took me several years to write this book. I used several sources. The common body of knowledge, of course, the CBK is the most authoritative source. I also used the late great Sean Harris's all-in-one study guide. It's a phenomenal book. I used several practice question exam books that had explanations, very good explanations of key terms and concepts, and then the internet, of course. So I went through all these sources. I tried to group together the smallest grouping of terms that I thought would help you pass the exam. So I tried to, I categorized all these terms into either just terms, informational notes, concepts, and something I call muscle memory, which is all those algorithms and the OSI model and the ports and protocols and all that stuff that's just muscle memory that we have to memorize. I broke that out separately so that you could print out those muscle memory charts and focus on the muscle memory separate from understanding the terms and the concepts that I want you to know. So the focus of my book, of this course material, is to identify key terms and to expose you to those key terms in many different ways. I went through a couple of boot camps myself. I've taught boot camps with other people's course material, and what I've felt from those classes is that they were just throwing a bunch of information at you, just a ton of information. There's no way any of that stuff was sticking. So the intent of my program is to identify key terms so that when you're taking that exam and you're reading a test question, you see 3 or 4 key words, and those will point you to the correct answer. So we go through, as you go through this video series, you'll see these and hear these key terms. When we play rounds of Jeopardy, they're focused on these key terms. And when you test your knowledge with Kahoot, you're going to see these key terms again. So multiple times you're seeing these key terms and they're just embedded in your brain. Folks. So you could purchase the book, read the book. You could listen to the audio, which is just a verbatim, word for word illustration of the book. You can read or listen to the audio and follow along in the book at the same time. You could purchase the video series that you're looking at now, the full version of the video series for all 8 domains, which is the video recordings are a recording of a boot camp we just finished a couple of weeks ago. It turned out a lot better than I expected, and I think it can be really helpful. You could also watch or compete in rounds of Jeopardy, which, after you've gone through all the material and you're ready to see where you're at and test your knowledge, there are 15 rounds of Jeopardy to get through all 8 domains. But then Kahoot. Kahoot is something that we do on a weekly basis in the evenings. You could, if you go to the website and purchase the ability to compete in one of these competitions, there's one for each domain. The number of questions varies, but after you compete in this competition against other people who are preparing for the exam, it gives me a spreadsheet of every question and every answer, whether you answered wrong or right, so that I can sit down with you and know where you're weak and where you're strong. The people who compete well at Kahoot pass the exam the first time, every time. So the question that I often get, I think I get more often than any other question is, what's my success rate? How many of my students actually pass the exam? So I've been teaching CISSP boot camps with my own material for about 5 or 6 years. I've been teaching the boot camp for over 10 years, but all of my students pass the exam. If you go through my entire boot camp, I can tell you with the Kahoot rounds and the printout, the spreadsheet that comes out of that, I can tell you whether I think you're ready or not. If you're ready, you take the exam, those people pass every time. If you're not ready, I'll tell you, and I'll tell you what I think you need to work on. Now, I've had some folks who took the exam anyway, even after I told them that I think we need more time. They didn't pass the first time. I worked with them some more afterwards, and they passed the second time. So really, it's up to you. If you can get through all of this content, it's a marathon of material to get through. If you really want it, if you really need it, then if you can get through all of this content, I am very confident that you can get through the first time. But I would need to see you compete on Kahoot rounds in order to know for sure whether I think you're ready. All right, guys, that's it. Welcome to the program. Welcome to this journey to cybersecurity. It is the fastest growing industry in the world. It's the most exciting, in my opinion. I love what I do. I love working with this stuff. I love talking about it. I love sharing information. So again, if you're interested in the full version, go to www.cybersecstudy.com and take care. All right, Domain 7, Security Operations. And the way I organize this material is such that it'll flow in a logical manner. And as we get to these later domains, we should be seeing stuff that we've seen before or stuff that we've talked about before. So Security Operations Center, this is, I wouldn't mind working in a SOC. I've helped develop some policies and procedure documents for SOC operational environments, but a lot of folks I know work a day job, especially single folks. They work a day job and then they work a night job on the night shift at a SOC. Instead of sitting at home watching TV, they're watching a monitor and making money. Wikipedia defines a security operations center as a location where you have enterprise information systems, websites, applications, databases, data center, servers, networks, desktops. All of these information systems are monitored and assessed and defended. So they have environments that look like this picture here. I've seen some really nice SOCs before throughout my career. Security management, we see that word management again. Involves the implementation of security controls that an organization implements in order to ensure that it's managing the risk of loss, misuse, disclosure, damage to the information technology assets. So, is there a difference between an event and an incident?
Most definitely. An incident is an event that occurs when it causes a disruption in service.
Oh, when something bad happens, anything that violates the security policy could be considered an incident. But an event is just something that happens. You know, the automated audit log tools on our systems are generating events for everything that happens on the system. When you turn the system on, an event is generated. When you log in, an event is generated. When you attempt to access the resource, whether it was successful or not, an event is generated. You can have these physical monitoring tools that whenever you open the front door to a building, an event can be generated. Whenever you pass access control, physical access control system, an event is generated, but it's not an incident unless it has a negative connotation, unless something bad happens. An event is not necessarily bad, but an incident is an event that is bad.
And Don, the incident is also when it affects the security posture, the incident
Yep,
of the system.
sure. It violates the security policy or affects the security posture. Yep. All right, all incidents are events, but many events are not incidents. If an event has a negative connotation or something bad happens, if it violates the security policy or the security posture, then that event becomes an incident. Asset management, we keep seeing that word everywhere we go. Asset is anything that a company places value on. People, physical property, and intellectual property. We must first identify all of our assets, assign a value to them, manage their location and status, monitor the value in case it increases or depreciates. You should manage the entire life cycle of assets from procurement to installation, operation, maintenance, modification, all the way to decommissioning. Configuration management, after you've hardened your system by configuring them in a secure manner, ensure that they remain configured that way unless there's a justifiable reason for why they should be configured differently. Vulnerability management is really all we're doing right now. We're not doing risk management. But if you have configured your system components securely, chances are that you won't have very many vulnerabilities, but every system is going to have some, no matter how secure it is. The only secure system is one that doesn't provide any functionality. Throughout the life cycle of every system component, you must identify existing and new vulnerabilities, assess the risk of operating the systems with these weaknesses, classify or group each vulnerability, and mitigate or accept each weakness. Contingency is an event or circumstance that's possible but can't be predicted with certainty. Well, contingency planning involves developing a strategy for how to respond quickly to potential incidents. If anyone's participated in a contingency plan test, the scenario that they always give is a meteor crashes through your data center. In which case, if you purchase cloud services, then you don't have a data center. You don't have to worry about this. Or if your cloud service provider's data center has that proverbial meteor strike, then they've got a backup facility and they can be back up within minutes or seconds in some cases. But with a contingency plan, you want to look at what are the components of your system. Is the system I manage only consisting of telecommunications and the physical servers? If that's the case, then a contingency plan test might be what happens if there is a flood? You know, what happens if the RAM goes bad in one of my PCs? Who's going to respond? How are they going to respond? What's the call tree in case the first person is not available? Penetration testing involves attempting to overcome an organization's security controls in an attempt to understand what the organization is vulnerable to. So we usually do vulnerability testing just to identify weaknesses, and then pen testing to try to circumvent those weaknesses. Fingerprinting is an information gathering technique, allows the attacker to gain information about your organization or your network. This is a passive attack. when you're gathering information, footprinting. Anybody knows their Kali Linux, or a lot of tools in there that can help you do this. Port scanning is also an information gathering technique. A port is an internal or is an interface, and external devices and internal devices connect to a computer via these ports. So if you run a port scanner on a system and identify what ports are open, that'll tell you what applications are running on that system. Most applications use specific port numbers. You see that port is open and running, then you can surmise that that application is on it. Then you can identify are there any zero-day vulnerabilities available, to this application, or any known weaknesses on this application that may not have been patched. And then find the attacks that can help you circumvent those vulnerabilities. Packet analyzer could be a hardware device or a software application used to capture data packets as they traverse from one system to another. Auditing, we keep seeing that word audit. I always think of automated audit log tools or the KPMG financial audits with an auditor coming in. Auditing works just like the black box in an airplane. That device that they want to capture every time a plane goes down, that thing is capturing everything that happens. Every switch or button on that plane that a pilot touches, or every word they speak, all that information is captured. That's what automated audit log tools are like, the black box in an airplane. If an attacker gains unauthorized access to a system via a common user account, they might be able to elevate their privileges to that of an administrator and then delete the audit records so that no one could look at the logs to see what they've done. So you want to have these logs forwarding in near real time to a central repository. Fault tolerance is the ability of a system to respond gracefully to an unexpected hardware or software failure. If it has a failure, is it just going to die, or is it going to be able to respond in a way that allows it to keep running? Redundancy is the duplication of critical components or functions of a system with the intent of increasing reliability of the system. And then system backups involve storing copies of data from one storage media to another so that it can be recovered if the original storage media is compromised or damaged. All right, important slide here. Disk mirroring and shadowing are the same thing. With disk mirroring or shadowing, two storage media devices are configured so that data is written to both devices at the same time. If one device fails, the other device will pick up the load so that users don't experience any downtime. That is fault tolerance when you have disk mirroring or shadowing. Disk striping doesn't necessarily provide any fault tolerance. Data striping involves distributing chunks of data over multiple disks. There's no mirroring or parity, so there's no redundancy or fault tolerance. It improves performance, but if even one disk in the array of disks fails, the disks are no longer connected and the array is unusable. So when we start talking about these mirroring, shadowing, striping, we're talking about not just staving media on one drive like we do as consumers on our laptop. We click save and save it on this one drive. Organizations will have multiple drives that are configured into an array in several different ways so that if one media device in the array goes down, the other one can pick up. Or with striping, you'll have multiple disk media that can information. If you click save to save a file, then one bit can be put on drive 1, one bit on drive 2, next bit on drive 3, next bit back on drive 1. They can stripe them across all the available disks in that array. It could be by bit, it could be by byte, it could be by a block of whatever size of data. But striping Doesn't provide any fault tolerance. All it does is copy a bit or store a bit on one drive, the next drive, the next drive. It stripes them across multiple drives. We have different types. Well, let's talk about parity first. So if a drive fails, you have multiple drives in an array. If one of the drives fails, the parity is basically instructions that tell the RAID run it redundant array of independent disks. We'll talk about that in a minute. Instructions that tell the array of drives or media how to rebuild the lost data on the new hard drive. So parity is used to rebuild a new drive so that all the information is restored. And they have this thing called this parity bit. That word bit again, we talked about bit with respect to cryptography, and the number of bits determine the key space, the number of keys that were going to be available. We talked about bits with telecommunications, and the number of bits determining how many IP addresses were available. Now we're talking about these bits with respect to parity. Parity adds a single bit that indicates whether the number of 1 bits in the preceding data was even or odd. And this is going way too deep. All we need to know is that if you have striping without parity and one of the drives in your array goes down, then you lose that information. But if you have striping with parity, then you're not going to lose your information. Different types of parity. We don't need to know too much about these other than just know what parity is and what it does. Hamming code parity is used to identify errors when information is moved from one location to another. Byte level parity is used. When it's used, bytes of information are striped across multiple drives. The parity data is held on one drive. We talked about the fact that you could stripe bits, bytes, or blocks. Block level parity. When block level parity is used, blocks of information are striped across multiple drives, and the parity data is held again on one drive. And then interleave parity is when is written to all drives to ensure no single point of failure. And then double parity, a second chunk of parity data is written to all drives. So we'll talk about these in greater detail in a minute, but essentially, if you just have striping, you don't have fault tolerance. But if you have striping with parity, then you can have one drive in your array go down and you can still recover it. But if you have 2 drives in that array go down, then you're hosed. But if you have interleave parity or double parity, then you can have multiple drives go down and not lose all of your data. Has anybody heard of this term JBOD, just a bunch of disks? Refers to a group of computer hard disks that are made to appear as one large disk drive, but it's not configured to provide redundancy or fault tolerance. Made massive array of idle disks, similar to JBOD. You could bring a bunch of media, a bunch of hard disks together and have them appear as one large disk, except made includes power management. So you can allow drives to only spin up when data is being accessed on those drives. And then with rate, redundant array of inexpensive or independent tapes, provides fault tolerance by striping data across multiple tapes. And then RAID, redundant array of independent disks, provides one of the best methods for providing fault tolerance. Wikipedia defines RAID as a storage technology that combines 2 or more disk drive components into a logical unit. Data is distributed across the drives in one of several ways called RAID levels, depending on what level of redundancy and performance is required. So let's talk about each of these, and we've got a muscle memory chart for these. That's very important. And I want everyone, to get to the point. We've got to get to the point where we're getting hundreds on these Kahoot rounds. I don't want you taking the exam unless we're getting hundreds on these Kahoot rounds. And you have the confidence of knowing that if you miss one, it's a, oh, what the heck? I made a mistake or something like that.